All right, so the last thing we're doing with the warm-up is the equation of the tangent line. So equation of a tangent line. So when we have a line, it is going to end up being in slope-intercept form. And what is that? Y equals mx plus b. And when we were talking about a function notation, the y and the f of x are the same thing, so we would write it in function notation as that. So the other warm-ups gave us the fact that the slope was 4. Now, where are we having this tangent line happening? It is at x is equal to -1, which we had above. So then we need to know what is the function at -1 value. And if you recall, we had the number 1. Let me just go ahead and write what that original function was, just so you can remember. All right, so we're finding the equation of the tangent line at -1. This information right there gives us the coordinate point, input of -1, output of 1. So all we need to do now is 2 different ways, and I'm going to show you both. The point slope way of determining the equation of the line. So if you remember, y minus y1, m, x minus x1. So we would plug in the m right there. We're going to plug in the x, which was a -1, and the y1 value is 1. We get 1 minus 1. I'm going to go ahead and distribute this. 4x plus 4. Add the 1. Add the 1. Y equals 4x plus 5. Hold on, let me make that a little bit nicer. 5. Okay, here we go. And then to write it in function notation, we would have f of x equals 4x plus 5. The other way to do it, which this is kind of the way of finding the b value that I like to do. So what is the y? 1. What was the slope? 4. What is the x value? -1. We are figuring out b. 1 equals -4 plus b. Add that 4 over. B is equal to 5. We have that exact function because we have y is equal to 4x. Our b value was 5. Turn around and write it in that notation. And if you notice, either way gave us the same equation of the tangent line. So this is the tangent line at -1, 1 on that original function, which is a upside down quadratic. All right, there you go. See you next time.